Question 11 is about some resistive putty, two pieces of the same length made from the same material. It tells you that the diameter of y is twice that of x, so I've called the diameter of y d and the diameter of x d over 2. And it tells us that the resistance of y is r, so I've written down resistance is resistivity times length times area. And then I've substituted in, assuming that it's circular, that the cross-section area is pi d squared over pi r squared, or pi d squared over 4, and that gives me the resistance of y is equal to, that's for y, 4 rho L pi d squared. And let's do the same for x, so let's work out the resistance of x, that's y. That's going to be rho L over A again. In this case it's rho L over pi. Now this time it's this is d squared over 2, so the radius is going to be d over 4 all squared, which is going to give me rho L, or 16 rho L, because that's squared, and then over pi d squared. Okay, and because they're in series, we're going to add them together, so we're going to add ry and rx. So I can take the rho L over pi d squared out, and I get 4 plus 16, like that, and that gives me 20 rho L over pi d squared. So the combination rx plus ry is 20 rho L pi d squared, and when I compare that with r, which is the resistance of y, which is up here, I can see that it is 5 times larger. So in fact the resistance of the combination, this one here, is 20 rho L pi d squared, whereas the resistance of y, 4 rho L pi d squared, is 5 times larger. So in fact the resistance of the combination is 5r, so it's 5 times larger. So the answer for question number 11, when I look down the answers, I can see the correct answer is D.